The Edison base fuse with the hex window is a 15 amp fuse because the hex shape is distinctive and easily identifiable. This design helps distinguish it from other amperage fuses, preventing accidental mismatches that could lead to electrical hazards. Firstly, visual differentiation is key. The hexagonal window stands out visually from the round windows of higher amperage fuses. This makes it easier to quickly identify the correct fuse for a given application. Secondly, the hex window serves as a safety measure to prevent the installation of a higher amperage fuse into a circuit designed for 15 amps. The hexagonal shape makes it impossible to insert a larger fuse that could overload the circuit. Thirdly, the Edison base fuse was one of the first electrical fuses developed, and the hex window has become a recognizable symbol of the 15 amp fuse over time. Fourthly, the hexagonal window has become the industry standard for 15 amp Edison base fuses. This consistency allows electricians and homeowners to easily identify and select the correct fuse for their needs. The unique shape of the hexagonal window makes it difficult to counterfeit 15 amp fuses. This helps ensure that authentic fuses meet safety standards and reduces the risk of using substandard or dangerous products. Fuses are critical components in electrical systems, acting as sacrificial devices to protect circuits from overcurrents. When the current exceeds the fuse's rating, the internal element melts, interrupting the circuits and preventing damage to equipment or potential fire hazards. The Edison base fuse is an older type of fuse characterized by its screw-in base, similar to that of an incandescent light bulb. While newer fuse types like cartridge fuses and blade fuses are more commonly used in modern applications, Edison base fuses are still found in older installations and some specific applications. A 15 amp fuse, as the name suggests, is designed to interrupt the circuit when the current exceeds 15 amps. This rating is crucial because it aligns with the safe current carrying capacity of the wiring and devices connected to that circuit. Overloading a circuit by using a higher amperage fuse can lead to overheating, insulation damage, and potentially electrical fires. The hexagonal window on a 15 amp Edison base fuse provides a quick and unmistakable visual cue. This is especially useful in situations where multiple fuse ratings are present and a quick glance is needed to ensure the correct fuse is being used. The contrasting shape helps prevent errors that could arise from misreading labels or confusing different fuse sizes. Consider a scenario where an electrician is working on an older electrical panel. The panel contains a mix of fuse ratings, and the lighting is not optimal. The hexagonal window on the 15 amp fuse instantly distinguishes it from the other round window fuses, reducing the chance of accidentally installing the wrong fuse. The hex window's design directly contributes to electrical safety. By physically differentiating the 15 amp fuse, it reduces the likelihood of someone replacing it with a higher amperage fuse. For example, if a 20 amp or 30 amp fuse were installed in a circuit designed for 15 amps, a circuit wiring could be overloaded without the fuse blowing. This could lead to the wiring overheating, potentially causing a fire. The unique shape makes it difficult, if not impossible, to insert a larger fuse into the fuse holder designed for a 15 amp fuse. This physical incompatibility provides an additional layer of protection against overcurrent situations. The Edison base fuse is a historical artifact of early electrical systems. Its design reflects the technology and safety considerations of the time. The hex window on the 15 amp fuse is a reminder of these early standards and the importance of proper fuse selection. Over time, the hex window has become synonymous with the 15 amp Edison base fuse. This association has helped maintain consistency and reduce confusion in the electrical industry. The standardization of the hex window for 15 amp Edison base fuses has several practical benefits. Firstly, it simplifies fuse identification for electricians and homeowners alike. This is especially important for those who may not have extensive electrical knowledge. Secondly, it reduces the risk of errors during fuse replacement. The consistent shape and appearance make it easier to select the correct fuse even in challenging conditions. Thirdly, it helps maintain safety standards across different manufacturers and suppliers. The widespread adoption of the hex window ensures that all 15 amp Edison base fuses adhere to a common visual standard. The unique shape of the hexagonal window makes it more difficult to counterfeit 15 amp fuses. Counterfeit fuses may not meet the required safety standards and could fail to protect circuits from overcurrents. By making it harder to replicate the 15-amp fuse, the hex window helps ensure that only genuine, certified fuses are used. Counterfeit electrical products pose a significant risk to safety and property. Substandard fuses may not have the correct amperage rating, may not blow reliably, or may even create a fire hazard themselves. The distinctive shape of the hex window adds a layer of security against these risks. In addition to the hex window, other features of Edison-based fuses contribute to their safety and functionality. The fuse body is typically made of an insulating material, such as glass or ceramic, to prevent electrical shock. The metal end caps provide electrical contact and secure the fuse in a fuse holder. The internal fuse element is made of a material with a specific melting point, allowing it to break the circuit when the current exceeds the rated amperage. When selecting and installing Edison-based fuses, it is essential to follow all applicable electrical codes and safety guidelines. Firstly, always ensure that the fuse amperage rating matches the circuit's requirements. Secondly, never replace a fuse with a higher amperage fuse. Thirdly, inspect fuses for any signs of damage or wear before installation. Fourthly, use a fuse puller to safely remove and install fuses. Fifthly, turn off the power to the circuit before working on fuses. Furthermore, consider the specific application when choosing a fuse. Time delay fuses, for example, are designed to withstand temporary overloads such as those caused by a motor starting without blowing. These fuses are often used in circuits that power appliances or equipment with high inrush currents. Fast-acting fuses, on the other hand, are designed to blow quickly in response to overcurrents. These fuses are typically used in circuits that require sensitive protection, such as those containing electronic components. The hex window on a 15-amp Edison-based fuse is a simple but effective design feature that contributes to electrical safety and ease of use. Its visual distinctiveness, safety function, historical significance, industry standardization, and reduced risk of counterfeiting make it an important element of this type of fuse. Understanding the purpose and benefits of the hex window can help electricians and homeowners make informed decisions about fuse selection and installation. The principles behind the hex window design can also be applied to other electrical components and safety measures. For example, color coding, labeling, and physical barriers are all used to differentiate and protect against hazards in electrical systems. By emphasizing the importance of clear and consistent visual cues, the hex window design serves as a valuable lesson in electrical safety and best practices. Electrical safety is paramount in all aspects of electrical work, from design and installation to maintenance and repair. Proper fuse selection and installation are essential for protecting circuits, equipment, and people from the dangers of overcurrents and short circuits. The hex window on a 15-amp Edison-based fuse is a reminder of the importance of these fundamental safety principles. In modern electrical systems, newer fuse types like cartridge fuses and blade fuses offer improved performance and safety features. However, the Edison-based fuse with its hex window remains a part of electrical history and continues to serve a purpose in older installations. Understanding the characteristics and applications of different fuse types is crucial for anyone working with electrical systems. Whether it's an electrician, a homeowner, or a student learning about electrical technology, knowledge of fuses and their safety features is essential for ensuring safe and reliable electrical operation.